So hi friends, good evening. So welcome to the automotive analytics training by 360DigiTMG. So yesterday we discussed about introduction of automotive analytics. So it is nothing but part of each step of the product life cycle, and it is nothing but understanding the behavior of the consumers, their purchases, and so that we can take some decisions. So now today, as I informed yesterday, so we'll discuss about CRISP MLQ methodology. So before going to CRISP MLQ, so what is machine learning? So we need to understand machine learning and AI, artificial intelligence. So machine learning is nothing but based on by passing the data and algorithm, so machine can understand, machine ready to give some predictions. That is nothing but machine learning. So how we are learning? So machines can learn so based on data and the suitable algorithm. And artificial intelligence is nothing but development of artificial intelligent machine, and the machines will work and think like human beings. Now why? So what is CRISP MLQ? So as a machine learning will give the correct answer predictions by understanding, by analyzing the data. So the many organizations and the data machine learning practitioners need guidance. So entire the development of the machine learning application. So that is so that organizations are proposing one model. So that model is nothing but CRISP MLQ. So CRISP MLQ stands for cross industry standard process for the development of machine learning applications with quality assurance methodology. So this CRISP MLQ also nothing but project management methodology. So any data science project, if we take any project, so these steps we need to focus. So these 6 phases are very important to develop a machine learning project. So today let us understand clearly. So what is CRISP MLQ? So it is for development of machine learning applications with quality assurance. It consisting of 6 phases. Today we will discuss clearly regarding each and every step. Yeah. So today's agenda is nothing but CRISP MLQ methodology, and what is machine learning, and what are the types of machine learning, and finally machine learning in automotive analytics. So let us start with CRISP MLQ methodology. So CRISP MLQ nothing but project management methodology. There will be 6 steps. So this is 6 steps, starting from business understanding and data understanding. So data preparation, model building, testing and evaluation, deployment, finally monitoring and maintenance. Now first step is nothing but whenever you have any problem statement, any project with respect to automotive industry, so the problem statement either releasing of increasing of the pollution or toxic gases, any use case we can take. So for that, what are the challenges? So we need to understand the problem statement. So after understanding, we need to note down the objectives and constraints. So business objectives are nothing but the measurable things which company has to maintain to reach their target. And that is completely based on the problem statement. Suppose if different company vehicles, their pollution is increasing, they are releasing more amount of carbon dioxide. Now the business objective is nothing but minimize the pollution. Okay, so maximize the usage of fuel. So like that, the objectives and constraints. Constraints are nothing but limitations, so which will not allow us to reach to the target. So we need to note down that objectives and constraint before proceeding with the project. So after business understanding, then if we have the data, we need to go with the data. So what type, how many columns the data has, so what is the relation between the each and every columns. So data we need to understand. So if we understand data only, so what we need to predict. So are we going to predict value, or are we going to classify the model, etc. So for that we need to go through with each and every column in the data. So this is nothing but first phase, nothing business understanding and data understanding. If everything, if it is clear, then we will go to the data preparation. So data preparation, it is also nothing but data engineering. So data engineering is a combination of exploratory data analysis, so data preparation is nothing but EDA and pre-process. Data preparation of EDA and pre-process. So exploratory data analysis is nothing but statistical analysis on the data. So what are the various columns? What is the relation between the each and every column? And what will be the mean, median, mode? Some statistical measurement. So that will helpful for our analysis, further steps. Next in EDA, we can notice, so do we have any outliers or any values? Even we have auto EDA libraries. This auto EDA libraries help us to what steps we need to take for the data. So when EDA is performed, then EDA, then we'll immediately focus on data pre-processing. So pre-processing is nothing but arrange our data for model building. Suppose if our data having NA values, if our data has outliers are nothing but extreme values. If the data points are nothing but 1, 2, 3, 4, 5. So one of the data points is nothing but 100 or 1000. So that value is extremely different than the other values. That is nothing but outliers. So in our data set, if we have such type of outliers, or if the data set consisting of missingness, so it is very challenging for the next step. And even if you go with model building, if you go with the same data to the model building, so the model can predict the wrong values. So this is very important step in the CRISP-MLQ methodology. So ED and pre-processing. So then after, so when if the data is clean, if the data is not consisting of any outliers, so then we can go with model building steps. So before going to the model building step, so let us understand types of machine learning. So as I explained already yesterday, so types of machine learning. So machine learning is broadly classified into 4 types. So first one is supervised machine learning. And second one is unsupervised machine learning. Semi-supervised machine learning. Reinforced. So let us understand, because in the model building step, we will try with various models. We will try various models for the data available. Then after trying the various model, which model is giving good accuracy, that we will consider. Now, why we need to discuss regarding types of machine learning before going to the model building, because there will be a different types of data set, different data set we have, and the output also. If our data set output variable, the output, if we have the output, definitely it is a supervised model. And if there is no output in the data set, so the data is nothing but some characteristics, some nature. So we are going to predict, or we are going to make into groups. So that comes under unsupervised learning. And maybe as per our requirement, sometimes we need to apply two techniques, either supervised and unsupervised. And one is nothing but with respect to games. By playing the score, we can improve. So these are the various types of machine learning. Now, these are we must know before going with the CRISP-MLQ methodology. Next, so let us focus on supervised machine learning. So already I explained yesterday. So if we, in our data set, if we have the output variable, definitely that comes under supervised machine learning. So we can predict the output. So what will be the output in future? There will be a data point for the data in our data set. For different data point, there will be outputs. And when the future in the future, if there is any new data point, we can predict the output value. So based on this method. And supervised machine learning, again, so it is based on output variable. We have two methods. One is classification models, another is regression model. So whenever if the output variable is continuous, we use a classification model. If our output variable is nothing but continuous, we can go with regression models. Yeah, this is about supervised machine learning. Next, unsupervised machine learning. So as I have explained example yesterday also, regarding if we serve one basket, so which consisting of different types of fruits. So now we can, if we apply the machine learning, so for in that cases we can use unsupervised machine learning, so that each and every fruit separated based on the characters. Like now there is some scenario we can apply both techniques, either supervised techniques and also unsupervised techniques. Such type of machine learning is nothing but semi-supervised. And yeah, gaming applications that uses reinforcement learning. So now in the model building, what will happen exactly? So after cleaning is done, then what algorithm we need to apply? Suppose if the output variable is continuous, then we will apply various regression algorithm, and after applying each and every algorithm, then we can compare the results and which algorithm is giving good results. So that we will take for further step. We may try with 4 or 5 some number of algorithms. So that things we will discuss in model building. So when the model building is completed, then we will test and evaluate the results. Like what will be the training accuracy, what will be the testing accuracy. So 3 things we will discuss more in the testing and evaluation, like training data, testing data, validation. So first validation data, first testing is nothing but validation. So we will compare the results. So what accuracies between the training and testing. Suppose if both are okay, then we will deploy that model into the production. Deployment is nothing but we will get one app. So that now our model is ready to predict for the new data points. So machine can understand, after understanding the complete data by the analysis, when the particular new data points comes, what will be the output. So that will be done by the deployment. So once the deployment is done, so it is not completed, there is another step, monitoring and maintenance. Because so we can apply these steps one by one step. When we have the data, first we need to understand what is the problem statement, and then we note down, or we can work on what are the business objectives and constraints. So then data understanding, after we will prepare our data for model building. Model building, we will try with various machine learning algorithms. So after which model is giving good accuracy, then we can consider for the deployment. It is fine. But whenever if your model is ready to predict values, when the time is passing, after some time, the accuracy of the model gradually reduces. That is, property is nothing but staleness. Now when you run that model, so last time you got accuracy around 95, 94. You feel that yeah, it is giving good accuracy, fine. Then you will deploy the model. when that model is ready for the real-time data, whenever you are adding, when you are testing that model with real-time data, gradually the performance of the model is reduces. That is nothing but model staleness. Staleness is nothing but after some time, the machine learning model is just the accuracy of the machine learning model reduces. Such property is nothing but staleness. Now that is overcome by the retraining the model. So retraining is happened, monitoring and maintenance. So when there is a chance, whenever the model accuracy is decreasing, at that time, again retrain that model. So after retraining, just with the correct hyperparameters are nothing but the things so which will increase the performance of the model. So various hyperparameter we will use to increase the performance of the model. So these are the things that happen. So in monitoring and maintenance, so it will check whether the model accuracy reduces, it will retrain the model. So again, same deployment will happen, again monitoring. So it is continuous process, so that the machine learning engineers, they will get complete guidance entire life cycle. So it is continuous process. So this is simply nothing but CRISP MLQ methodology. So next comes, so what is machine learning? So machine learning is a branch of artificial intelligence and computer science that focuses on the use of data and algorithms. So machine learning, it is nothing but branch of artificial intelligence and computer science. So mainly focus on uses of data. So a lot of data is releasing due to the various sources. Now use the data and various machine learning algorithms to imitate the way that humans learn. So how we are learning the new concept in our daily life, how you are predicting some value, same way machines will do. So gradually it improves accuracy. And it is an important component of the growing in the field of data science. So it is essential part in machine data science. And through the use of statistical methods, algorithms are trained to make either classifications or prediction key insights within the data mining projects. And these insights subsequently drive the decision making within applications and businesses, ideally impacting key growth metrics. So definitely that machine learning concept will help. It will give us what decisions are gives good results in future. What are the predicted values? What steps we need to take to reach goal, etc. So we can get more insights by the machine learning concept. So yeah, you can able to see here unsupervised learning. So see in the unsupervised learning, just the training. So historical data. Some 2 years of data, 3 years of data. So historical data, and then we are applying the machine learning. Now the machine don't know about the output variable. Machine don't know anything regarding the data set, but even after understanding the data, it will give rules or patterns. Okay. Yes. Yeah. So so now in the so unsupervised learning, just whenever we are giving the historical data, so by studying that historical data, the machine will give rules or pattern. So when a new data points comes, so which category the new data points it is belongs to, so it will give. So we can give rules or we can give patterns. So if you send some different types of fruits, so the machine don't know about each and every fruit, but it will separate based on the character. So apples one group, banana in another group, like that. Okay. So next come to the so you can see prediction. So what we can, if the new data point is comes, we can give, without having knowledge on that. So what is the pattern, what are the rules we can give. So this is nothing but unsupervised learning. Next, coming to supervised learning, you can see, so training and validation. So we can give historical data, random sampling. Now we will take the data, we have the output variable, and with the output variable, we can split training and validation. So we will split the data into 80 and 20. So 80% training is done. So 20% testing. So we will build model on 80% of data, and we will test that model with 20%. Then you may get some mathematical equation. If it is a regression problem, beta not 1, x plus, etc. So one mathematical equation you will get. Now when the model building is completed, your model is ready to predict. Okay, so suppose if your data set is nothing but different months, what different number of sales, or your data set is regarding so CO2 emission. CO2 emission in the month of January, February, March, April, in 1 year data you have taken, and what will be the emission. Now it will predict. So supervisor learning will predict. So in next year, what should be the percentage of the pollution, etc. That is nothing but supervised. See here, predicting on new data. Suppose if you machine knows what will be the output variable, when your new data comes, then it will give the predict. So when new data point is nothing but, suppose we are going to predict the pollution in the month of next year. So in the next month or next year, so how much pollution it releases, and suppose today number of just some different number of vehicles comes to the market. In next year, how many? So like that we can predict. So by the supervised model. Next here we can focus on data split, model evolution and tuning. Now test on training data. So there will be errors. So training error, testing error, that should be minimized. Yeah. So this is about types of machine learning and CRISP MLQ methodology. Now, how the machine learning is applicable in the automotive analytics. So what are the applications in automotive analytics? First one is design and development of a machine. So designing and development of the various devices. So we can apply. So you can take how the device has to be improved. So how the design has to be improved. So by the challenges faced in the historical data. Next, to quality control and predictive maintenance, cost analysis, and supply chain optimization. So these are the use cases with respect to machine learning in automotive analytics. Yeah, finally, so in the automotive industry, so machine learning is most often associated with product innovations, and like self-driving cars and parking lane change assistant, smart energy systems, and ML also having significant effect on marketing function. So this is simply nothing but CRISP MLQ methodology with respect to our automotive analytics domain. Now, as from tomorrow, we can start with Python. So one programming language is required. So today, just I can introduce some concepts regarding the Python, because so yesterday's class and today's class only covers theory, and from tomorrow onwards, we will discuss and we can implement hands-on also. Okay. So now briefly I can explain. So what is Python? So Python, it is a high level. So it is a high level programming language, and especially it is plays an important role in the field of machine learning and artificial intelligence. And so it is have a lot of features. It is nothing but functional programming. It is functional programming. Functional programming is nothing but we can define number of functions, and So we can implement the results, and we can say it is also procedure oriented. There will be multiple procedure, and Python also object oriented programming. So object oriented programming is this total programming will be defined with respect to classes and also object. First we will define class. So class is we'll discuss classes and objects. So class is nothing but design, and objects are nothing but instances with respect to the classes. Now in Python we will define with respect, we can define classes as well as objects. So in that way the programming will be developed. And so coming to the advantages of the Python, just it is having rich library, it is dynamic programming, and first feature is easy to understand. So easy to understand. So while we are working with Python, so we feel that just we are discussing like English like grammar, so not any programming language. So that much it is very simple, easy to understand. It is dynamic programming. So dynamic programming is nothing but, so no need to declare the type of variable. So while defining, suppose when you define the data types, no need to mention which data it is belong, which data type it is belongs to. That's why it is called dynamic. SQL is nothing but static programming. So it is in dynamic nothing but no need to define the type of the variable. Yeah. So next we have easy to understand dynamic programming, modular programming. So modular programming is nothing but just Python, everything, each different modules we have. So each module is nothing but one .py file. So that .py file is nothing but some steps. Suppose if you want to perform some mathematical concept by using Python, we have math library. So with respect to the math library, what we can do, the total mathematical operations with respect to that model we can perform. Similarly, we have pandas. So in future, I think from tomorrow's class, we will discuss clearly regarding data sets. So from tomorrow, every day we will focus on data set also. So if you want to analyze the data sets, this is the important one. Pandas plays an important role. Pandas for analyzing the data. Like we have NumPy, it is working on arrays, and Matplotlib. For visualization. And one of the feature is nothing but library. So Python huge support of built-in library. We have so many libraries. So each library will responsible for one particular task. As it is providing many libraries, so many things we can perform by using the Python. So this is also one of the advantages. And even Python provide auto EDA. So auto EDA nothing but auto exploratory data analysis. So we can perform EDA, end-to-end results on the data. So auto EDA is helpful for how the data is distributed. So do we have any outliers? If we have the outlier, what is the percentage? And do we have any values? What is the percentage? So what steps we need to take to get good results? So the total information will be provided by the auto EDA concept. So these are the some features. So with respect to the Python, okay. And today we discussed about the project management methodology. So CRISP MLQ. So CRISP MLQ has six steps, starting from business and data understanding and data engineering. So in business and data understanding, we will work on the problem statement. So after working on the problem statement, we need to discuss the objectives and constraints. So objectives are nothing but the measurable things which will help the organization, what are the targets and etc. And data engineering, completely cleaning data takes place. So when the data is clean, the remaining steps will become easy, and there will be model building. We will try with various machine learning algorithms on particular data, and what model is giving good results, we can consider for the further step. We will test that model and we will deploy that model in the production environment, and finally there will be a last step, monitoring and maintenance. Because even after deployment, the model is ready to predict new values, but while the time is passing, the accuracy of the performance decreases. So in that cases, we need to retrain the model. Yeah. So as it is only the CRISP-MLQ methodology and some introduction Python, just yeah, I have concluding the session, and tomorrow we will start with EDA and data preprocessing. Thank you.